Welcome back. Today we will see the session on RNN implementation. So, what is RNN? RNN stands for recurrent neural network. Basically, we will be using this whenever you have a time series data. That is, your prediction depends on the last few samples. For example, we want to know whether what will be the temperature tomorrow. That tomorrow's temperature depends on the last 10 days temperature. So, we are predicting something based on the last few days data. So, that means there is some time dependent that is there. When we have a time series data, that is where we go for for these kind of an applications, we go for an RNN and LSTMs. So, for the first application that we are seeing here is we are predicting the next number based on the previous numbers. We can also use RNN for an applications like what will be the next word based on the previous sentence. So, here we are not dealing with an NLP application, here we are dealing with we want to predict the next number. Okay, so the very first is you are importing all the necessary packages. Here most of the packages is already known to you. The one important is because you are building an recurrent neural network, you are importing a simple RNN. And this you are importing from keras.layers. Rest everything train test split min max scalar is used for scaling down the values between 0 and 1, because you are building a sequential model, therefore it is sequential. Fully connected neural network or fully connected layers, therefore dense, and if at all if you are using a dropout, we can even use we can even import the dropout. Next, because we are dealing with a structured data and here we want to see a Google stock price prediction based on the last 10 days data. I want to know what will be whether I should invest in Google stocks or not. What will be my tomorrow's stock prices? Should I go ahead with investment or should I not investment? So, in order to go for these kind of an applications, RNN is a good model. So, here you are reading because the data is in a CSV format, you are using a function read underscore CSV. The data is stored in a variable data. You are printing the first 5 rows of data, and then you also want to know what is the shape, what is the size of this particular data. So, when you print the first 5, what is that we are seeing? We are seeing the date, we are seeing the features like open, high, low, close, and then the volume. So, what exactly is this? For a particular day when you have started, what was the open price when the stock was what was the open price for a particular day, what was the closing price when the market just before closing, what was the closing price for a particular day. During the day, what was the highest value and what is the lowest value. This is what is the description about this data set, and a particular date for a day, for a given day, what is the open price, what is the closing price, what is the highest price and what was the lowest price. So, this is what is the description about your data set. Now, what are we doing? We are whatever the data that is, whatever the date that we have, that date is in a string format. So, that has to be converted into a date time object. It has to be converted into a format which the model can able to take it. So, from a string format, if you want to convert that into an date time object, you have a function called to date time method. We have this particular function to underscore date time. What this will do, it will convert the date. Where is the date? The entire data is present in a variable data. Inside the data, we have a column called as date. So, inside the data, take a column called date. Now, whatever the value which is stored in this, convert that to date frame, date time. So, this entire is stored back into the same column. So, now why are we doing this? With this we can able to now extract. In this we have an year, we have a month and we have a day. So, now we can able to extract. So, from this particular column data date, extract the year, extract the month and extract the day and store it back in columns called year, month and day. So, what have we done? It is a simple operation. In our data set we have a date column, sometimes we will even have a time also. The time will be in hours, minutes and seconds. So, we will have date and time which will be in a string format. That string should be converted into date time object. So, that is what is being done in this particular cell. And you can see now when you print the head, earlier we just had only date, open, high, low, close and volume. Now along with this we also have a separate called year, we have a month and we have a day. This is what we have done it. Now, what is the requirement? There are many different types of RNN. We have many to one, we have one to one, we have one to many and we have many to many. So, let us take one two examples here and learn. Now, here the first type of RNN that we are considering is many to one. So, what is an example for many to one is, now I have a given sentence, whether that particular sentence is a positive sentence or a negative sentence or a neutral sentence. A particular sentence will have many number of words. So, from many your output what you are predicting is whether it is a positive or negative or a neutral. So, this is one example when you take an unstructured example. When we take a structured example here is, now I want to know many here is for a particular year, for a particular day. When you take a date has a year, month and day. So, for that particular date I want to predict what will be the open price. Now, if I have last 50 days data, with this 50 days, tomorrow for 22nd May, what will be the open price? I want to predict this. So, now what is the features that we are considering? The features that we are considering here is the date. When we take a date has a year, month and a day. So, how many features we are considering? The number of features that we are considering are 3. We are considering 3 features. Therefore, it is many. Now, what is your ultimate output? I want to predict the open. If I have last 50 days data, I want to predict what will be my tomorrow's open price. Google stock price, what will be tomorrow's open price. So, what is that you are predicting? You are predicting only one value. Therefore, it is many to one. So, what is many to one? We are considering many features, but ultimately your aim is to predict only one output. This is so this entire features is assigned to a variable called features, and that is assigned to a variable x. So, what does this x consist of? X is a features, and how many features we are considering? 3 features. So, next, whatever the values that are there, if you look into this, some values are very small, some values are very large. So, in order to avoid any sort of an biasing or model thinking that some feature is important, we are scaling down the feature values. So, how are we scaling down? We have seen already min max scalar. We are using min max scalar to scale down the values. What values we are scaling down? The values which are stored in x. So, we are scaling down the values, and we are then once we scale down the values, okay, that is what is your x which is ready. Now, we are taking the values which are there in y. What is stored in y? The value which is stored in y is this open. That is your ultimate prediction, right? Based on last 10 days or 50 days data, I want to predict open. So that means our aim is to predict this open. So this is our output. So that is our y is open. So now we are reshaping that. So because open is one single column value, which is a single dimensional vector. So what we are doing, we are reshaping it to, we are reshaping. So how are we reshaping? We are taking all the values of y which is otherwise in one dimension, one vector, single vector, we are reshaping it to -1 to 1. What is this -1? All the row values of y, whatever is stored in y, all the row values of y should be reshaped, and this one. So n cross 1. So now you see, which was in one dimension is now in 2-dimensional data. It is now in 2-dimensional. Why is that? It is just because the model needs the data in this format. Okay. So earlier you see when you print y underscore shape, you had the value 1258, and now after reshaping you are getting a value like this. Okay. So now what we have done so far, we have read the data, then because we are building many to one model, we have done some processing, we have scaled down the values, all this is being done. Now the most important concept here is you need to prepare a data set for an RNN. RNN requires a data in a particular format. So we have to now prepare that data set. So let me explain you with an example here. Okay. Let's take I have last 50 days data. I have first day open price, second day open price, third day open price, fourth day open price. I have like this 50 days open price. With this, what is your ultimate aim? Ultimate aim is to predict 51st day, last 50 days if you have the data, what will be my output on 51 day, the day 51st day, what will be my open price. This is what is the requirement. So how is that we build this one? So first 50 data that we take, and our y, the prediction, the expectation is this 51. 51 is the expected output. Next, we will take the next 50 data, that is from 0 to 49 is 50 data. Aim is to predict that next one. Next, I will now create the data from 1 to 0 to 49 we have prepared first, 0 to 49 we have prepared, and 50th one is what we are expecting. So now 1 to 50 we will prepare, and our aim is to predict 51. Then 2 to 50 and so on so forth, and our aim is to predict the next one. So I hope this is clear to you. Why we are doing this? This is how we are creating the sequence so that RNN can able to learn this. The last 50 days from day 1 to day 10, let us take example from 1 to 10, last 10 days data if I have, I am going to predict my predict the 11th day data. Next, what is that next I will do? We will take the data from 2 to 11, and our aim is to predict 12th. Then we will consider 3rd to 12th day, my aim is to predict 13th day. Then we will take 13th to 13 and aim is to predict 14th. I hope this calculation you have understood. So this is what we are going to prepare that sequence. How are we preparing the sequence? Time steps. Time steps is how many days data you want to consider. We want to consider last 50 days data. 50 days data, 10 days data, 5 days data. This is an hyperparameter. Now, the range, how is the range function works? The range function is you are taking all the data of your x. So, x is x scaled, the features. So, the length of your x scaled. So, from 50 to whatever is the length. Initial timestamp is 50 to the length of your input data, training data. So, initially 50 I value will be the first value, that is 50. So, what you will do, I value is 50 minus the timestamp time step is 50 to I value is once again 50. So, how is that we are going to do this? You see here the values that they have taken is I value is 50. We have 50 minus the time step is 50 colon I value is 50. So, what is 50 minus 50? 0 to 50. So, 0 to 50 is how many values? Is it not 49 is what it considers? For the first 49, what will be the output? The output will be the 50th one will be the output, correct? So, for the first, if this is clear to you, then let us go back. You see, for the first that entire is given to your x sequence, that is 49, and what will be your y value? The y value should be your 50th, 50 is your I. So, 50th is your y sequence, and you will repeat this for loop until when? Until you finish the length of your training data. So, x scaled whatever is value that you not the training data exactly, you will complete this for all the data that you have considered. Now, whatever is the values that are stored in your x sequence and in the y sequence, that is stored in the form of a list. So, that we are converting into an array format. We are converting that into an array format. So, and then store it in a variable x sequence and y sequence. Now, you have made the data ready which is required for your for the RNN model. Then you pass x sequence and y sequence to train test split. Then you will get x train, y train, x test, y test. So, up till now what we have done, we have read the data, we have prepared the data which is required for an RNN model. How RNN model requires the data, we have prepared the data according to that particular one. So, this is what first you will have 1 to 50 in 0th, and then 51th price will be your y. Then you will have from 2 to 51, then 52 will be the y, and so on and so forth. This is how you prepare your data set. You prepare the data set which is required for the RNN. This is the most important step when you are building an RNN, because it expects the data in the form of a sequence. This is one more example. If you have a data from x1 to x10, and if the time step is 3, then you will have x1, x2, x3, then you will have x2, x3, x4, x3, x4, x5, and so on so forth. And when you are writing x1, x2, x3, the prediction will be your x4. That x4 you are writing here. Then x2, x3, x4, your prediction requires your x5, that is what is written here, y5. Then x3, x4, x5, your prediction will be x6, that is what will be your y6. This is how you prepare your sequence. This is how the sequence will be stored in your x sequence and y sequence, and then you are converting that into an array, and then you are passing it into train test split. Then we are building an RNN model. How are we building an RNN model? We have seen that RNN model, you know, we use an activation function tanh, and what is an input that we are passing to an RNN? Look at this. What we are passing here is, what is the time step? The time steps here is 50. So, the input that you are passing here is 50, and y3, 3 is the features. How many features we have considered? We have considered 3 features. we have considered 3 features. So, input shape is 50, 3. And what we are building, look at the difference between look at the difference between the first one. You are building a sequential model, and first what we are adding is the first RNN layer. We are adding the first RNN layer, we are adding the second RNN layer, the third RNN layer, and the fourth RNN layer. So, we can say that it is a stack of 4 layers RNN model. Why? Because it is a 4 layer RNN model, stack of 4 layers RNN model. Okay. So, we can imagine this as let us imagine this in this way. So, it is an first RNN model has 50. I am just making you to understand the diagrammatic representation 50. Then we have a second layer. So, let us assume we have a second layer of RNN which has once again a 50. Then we have a third layer. So, we have a third layer, once again we have a 50 neurons, and we have a fourth layer. This is important point, fourth layer which has once again a 50 neurons. This is what is the architecture that we have built, correct. We have a first RNN layer which has 50, second RNN layer 50, the third RNN layer 50, fourth RNN layer 50. If you have observed very carefully, we have written it as simple RNN, but so far what was that we were writing? We were writing it as dense, right. See, the dense we are writing here, fully connected neural network, dense. And where are we writing this dense? We are writing this dense after the fourth layer of RNN. That means, we are writing this dense here after the fourth layer of RNN. That means, you will have connections here. This is how you will have the connections. So, we do not have connections here. We do not have connections here. We have connection only from that last layer of RNN to this the next. So, that is the reason you see this is the last one, this is first, second, third and fourth. For the first 3 layers, you are writing return underscore sequence. For the fourth one, there is no return underscore sequence. For the first 3 layers, you have return underscore sequence. And for the last fourth layer, there is no return underscore sequence. Because from there, by then the model has learnt, and from there it has to just now, from fourth layer it has to just give the prediction. So, now why there is only one that you have put? Because our requirement is it has to predict only open. Open is 1. Your aim is to predict only 1. So, that is the reason there is 1 neuron. And what is your aim? It has to predict open price, which is a number that you are predicting. Therefore, the activation function that you are using is a linear activation function. Rest everything will remain the same as your previous. Once you build your RNN model, you are compiling the model, because the loss function is mean squared error, Adam optimizer, and the metric you are using is MSE. Why we are using mean squared error? Because you are predicting a real number, you are predicting a number here. So, and then you are passing X train, Y train, you are training the model, epochs, batch size is 10, rather than passing all the training data, we are passing a 10 in batches. So, it is 10. So, once the model gets trained, we are going to evaluate the model. How are we evaluating the model? What is the function used? predict is a function used for I mean sorry, not evaluating, we are predicting now. So we have trained the model, we are predicting, we are passing X test. So predict, you are going to get the predicted value. So somewhere you have already scaled down the value, So what we have to do, when tomorrow's open price, if you want to predict, you have already scaled the value. So now you have to reverse that scaled one. So inverse the transformation. So you are going to get the actual open price. So that is your actual predicted value. Similar way, you have already scaled your entire y values also, that you inverse it. So you will get the ground reality, the actual open price, and what is the system predicted open price. And then you can also calculate what is other metrics, what is R square error and what is mean absolute error, we can calculate here. And this is merging the values and then visualization. So whatever the predictions that are come from y predict and y test true, we are going to flatten it, because here the predictions will be in the form of an array. We are flattening it and then we are printing. You can see here the predictions are like this. For a particular date, the open ground truth and then the predicted ground value. Open value is this, predicted value is this, open value is this, predicted. Because the performance is bad, because the performance is not good, you can able to reflect this in the loss value that we have got. So how can we improve this particular? You can improve by going and then changing the architecture. The kind of architecture that is built maybe is not performing very good. We can able to change this architecture. We can change this architecture. We can rather than having 5 layers, 4 layers, you can change number of time steps. You can change number of neurons that are placed can be changed, and you can see how the performance is varying. Whatever the cells that are written here, this is mainly used for visualization. So for visualization you are predicting, I mean we are writing these lines of code. So this is mainly for a visualization, and this is many to one. Let us take this is a diagrammatic representation of the predictions. Last 50 days, if the predictions are using matplotlib, you are predicting the values. So this is mainly used for a prediction, for visualization, for plotting the graphs. We have written this particular cell. So next we have many to, this is merging, rather than writing in two different, one is ground truth and one is predicted, one is ground truth open price, predicted open price. We can merge that in one single, that is stock price prediction. We can merge, that is this cell is mainly used for merging that into one single one. Then many to many. What is many to many? There we had considered many to one. So many to many, I will just scroll down and then show you only where there is a change. So here many features. So see here X we have considered many features. And earlier in previous example we had seen many to one, that means we were predicting only open price. Here I want to know, if I have last 50 days data, we want to know what will be tomorrow's open price and what will be the highest price. So open and high is what we want to predict. How many we are predicting? We are predicting 2. Therefore it is many to many. If it is 2, just see the change that we are going to do. In input it is the same time step and number of features here are 3. But look at this. Number of neurons that you put here is 2. Why 2? Because we want to go for 2 predictions, and we just because we are predicting 2, don't go for sigmoid activation or softmax activation, because we are predicting a number. So the activation function that we are using is linear. Rest everything will remain the same. Predictions. Then this is used for visualization. you are visualizing the date, open price and predicted, high actual and high predicted. So this is, and you are printing you are also calculating its loss, other loss values. So here I am stopping. What we have seen here is RNN implementation. In the next session we will see the implementation of LSTM. Thank you.